Hello dear student, myself Yogesh Kumar Sharma. I have completed my master degree from IIT Hyderabad by July 25. Today here I am covering a demo lecture here. So demo lecture will be shortly because we have no more time. So today's my topic is definite integral. So we will discuss here definite integral. So before moving forward, first I will discuss with you what is the definite integral, how can we solve the problem under definite integral. Okay. So, my topic is definite integral. So, what is definite integral? First, we will discuss. Like we have xy plane and this type of curve. Okay. So we are going to find out area of under this curve between the boundary x is equal to a to x is equal to b, like this area. So this is not a symmetrical geometry here, this is a curve. So we will draw a vertical strip here. This curve is equal to y is equal to fx. Okay. So we will take a strip, vertical strip here of dx thickness. So tell me what is the general area? Y into dx. Okay. So we want the complete area from A to B of this curve. Okay. So integral, what is the lower limit here? A, and the upper limit is B. A to B is equal to y dx. This is the complete area of this curve. From here to here, this is the lower boundary and this is the upper boundary here. What is the value of y here? AB fx dx. So here fx. What is the limit? A to b. So we will put first upper limit here. This is final expression. So what is y is equal to fx here? Y is equal to fx here is a continuous function. Continuous function between the interval, closed interval a to b, and here fx, this capital fx is antiderivative of your function small fx. This is the introduction of definite integral. Now we will move forward here. Now we will move forward here. Properties of definite integral. Properties of Our first property is integral a to b fx dx is equal to integral a to b ft dt. We can replace fx x by t here. This is the same. Okay. From integral a to b fx dx is equal to a to b ft dt. Okay. And the next property, integral a to b fx dx is equal to, if we will take the minus sign here outside the integral, so your limit going to inverse here, like b to a fx dx. We will move on the next property. Here, third property, integral a to b fx dx. Okay. So we can break it like this is the point A, this is the point B. From A to B, like between the point C is here. So we can break this integral A to C, sorry, A to C fx dx plus C to B fx dx. Okay, we will move the next property here. Property number 4. This is the property number 3rd. Integral A to B fx dx. We can write A to B, A plus B minus x into dx. And the fifth property, integral minus A to plus A, minus A to plus A fx dx. We are going to find this integral like this. Minus A to A. This integral is 0 when fx is odd function, and for the even function 2 times integral 0 to A fx dx when fx is even function. Now we will discuss what is even and odd function. What is even and odd function? For odd function, f of minus x is equal to minus fx. This is odd function. And for the even function, fx. So we will move the next property. We move to the next property here. Next property is integral 0 to 2a fx dx. So we can write it directly, integral 0 to a f of 2a minus x into dx. Okay. Now we will take a simple example here. Simple example here. Integral 0 to e x square dx divided by x dx divided by x square plus e. Integral kind attention please, 0 to e x dx by x square plus e. So here by substitution method from the indefinite integral, let x square is equal to t. So here 2x dx, this is the constant differentiation is 0 is equal to dt. So from here x dx is equal to dt by 2. So tell me what is the limit here? 0. Just put here 0. So now the limit going to change. Put the 0. Lower limit is e and put the e. Then e square plus e. This is the lower limit and this is the upper limit. Okay. So put the value into the integral. From here, lower limit is e here and upper limit is e square plus e. What is here your x dx? dt divided by 2, and from here x square plus e is equal to t. Just put here. Here 2 is the constant. Just take out from the integration. Integral e square plus e 1 by 2 dt by t. Tell me what is the integration here? dt by t. dt by t is ln t. So 1 by 2 ln t. Just operate the limit here, lower limit and upper limit. Okay. Just put the value 1 by 2. First upper value. Okay. ln e square plus e minus lower value ln e. Now further here we can take e outside from here. Okay, from here e square plus e we can take e outside common as a common. Okay, so here from here 1 by 2 ln take e outside. Here ln e plus 1 minus ln e. Here the formula of ln a into b. ln a into b. So what is the formula of ln into b? Here ln ab. ln a plus ln wait ln b here. Okay, ln a into ln b here. So we can apply 1 by 2 equal to, we can write this ln e plus ln e plus 1 minus ln e. ln e and ln e going to cancel. Okay, from here 1 by 2 ln e plus 1. This is our final answer. Okay, we will take the next example here. We will take the next example here. Integral limit, lower limit is 0 and upper limit is pi by 2 sin square x cos x dx. So here is the sin square x and here is the cos x. Let from here sin square x is equal to t. So not sin square is equal to t, only sin x is equal to t. Okay, so from here cos x dx is equal to dt. Okay, this cos x is equal to dt. So if you are going to take sin is equal to t, then your limit is also going to change. Okay, 0 to firstly starting your limit is 0 to pi by 2. Okay, so just put here at 0 this is 0, pi by 2 this is 1. Okay, now this is your limit. Just put value in this limit 0 to 1. What is your sin square x? Sin x t. Here t square cos x dx dt. Okay, so tell me what is the integration of t square dt? Simply t cube by 3 from here 1. Okay, 0 to 1. What is the value of t? Here sin x. Sin x. Sin cube x. 0 to 1. Tell me what is the value of sin cube 1 minus sin cube 0. This is 0, sin 0 0 and this is pi by 2. This is our final answer. Okay, so we will move the next example. 2 by 3, so sin cube x 0 to 1 and 3 from here also. So 1 by 3 and here is also 1 by 3. This is in bracket sin 0 0, sin 1 pi by 2. So multiply 1 by 3. Now this is your answer, pi by 6 your final answer. Now we will move the next example here. So next example is 0 to 3 mod x square minus 3x plus 2 dx. This is the modulus problem in definite integral. How can we approach this type of problem? Okay, so here this is the mod. Directly we can't solve this problem. Okay, first we will solve inside what is inside the mod plus or minus, then we will approach further this problem. So just take outside this inequality x square minus 3x plus 2. Okay, it's equal to 0. So factorize it. 2x minus x minus 2 is equal to 0. X minus 2 minus 1 here. Wait. Here is the plus, not minus. Here is the plus, not minus. X minus 2 take minus 1 common here and here also minus 2 is equal to 0. Equal to 0. Now we are going to the baby curve method here. So what is a here? 1 and this is 2. From the baby curve method, here is plus, plus, here is minus and here is plus. Means from minus infinity to 1, this is positive. Between 1 and 2, this is negative. And after 2 to infinity, this is positive. So now we are going to break this integral into different parts. Okay? Into different parts. So from equal to 0 to 1. From 0 to 1, this is positive. So x square minus dx plus 2 dx. Okay? Now next integral is minus 1 to 2 is minus there. Okay? So 1 to 3 x square minus 3x plus 2 dx plus in 2 to 3 now 2 to infinity, this is the positive. Okay? So 2 to 3 is x square minus 3x plus 2 is equal to dx. Okay? So solve this integral. What is here? X cube by 3, 3x square by 2 plus 2x 0 to 1 minus here x cube by 3, 3x square by 2 plus 2x. Sorry, 1 to 2. From here plus x cube by 3 minus x cube by 3 minus 3x square by 2 plus 2x 2 to 3. So just put the lower and upper limit in this integral. First one is, we are going to solve the first one from here. What is the upper limit? 1 by 3, then minus 3 by 2 plus 2. And the lower limit we are going to put here, and all the values are 0 from the lower limit. Okay? Minus from here 8 by 3 minus 12 by 2 plus 4 minus 1 by 3 minus 3 by 2 minus 3 by 2, 1 by 3 minus 3 by 2 plus 2. Now third integral, this is plus here 27 by 3 minus 27 by 2 here plus 6 1, and the lower limit 8 by 3 minus 12 by 2 plus 4. Okay, just simplify this. Here is the LCM is 6. Okay, so 2 3 is 6 minus 9 plus 12 in this integral. In this calculation, minus what is here 6 also 16 minus 36 here 24. This is 6 also here 2 minus 9 plus 12. From here plus here 6 also 54 here 81 2 3 is 6 26 7 27 3 is 81 here 36 minus from here 6 also 3 2 is 6 16 here 36 here 24. Now we will get this from here. From here, this is 12 to 14, 5 by 6. From first one, from here only 5 by 6 minus from here. This is 24, 24, 16, 40. 40 minus 36, 4 by 6. Minus from here, this is 5 by 6. From here, this is 97 by 6 plus 7 by 6. From here 4 by 6 minus 4 by 6. So just solve 5 by 6 minus 4 by 6. Just multiply inside 5 by 6 plus 7 by 6 minus 4 by 6. Take LCM 6 in all. 5 in numerator, 5 minus 4 plus 5 plus 7 minus 4. 5, 5, 10, 17. 5, 5, 10, 17. Answer is 9 by 6. This is our final answer. Now we will move to the next example. This is our problem. Integral minus 1 to 1 cos ln 1 plus f divided by 1 minus f dx. This problem is from minus 1 to 1. So first we will check this function is even or odd. Okay. So for even and odd, I told you earlier, for even function f minus f is equal to fx. This is for even. For odd function f minus f is equal to minus f. This is for odd. What is the function here? Fx is equal to cos ln 1 by x 1 minus x. This is our given function here. So first we would put, just replace x tending to minus x inside the function. Okay, inside the function we replace x to minus x. Okay, so here f minus x is equal to cos ln minus x divided by minus x. Okay, so we will get f minus x is equal to cos ln, here 1 minus x divided by 1 plus x. Okay, now we will take common minus outside. So minus x is equal to minus cos ln, just reverse 1 plus x divided by 1 minus x. So tell me, this is our odd function because f minus x is equal to minus fx, because fx is this function. Okay, so here integral minus 1 to 1, this is minus cos ln 1 plus x divided by 1 minus x. So I told you earlier, when the function is odd, then the value of the integral is actually 0. This is our final answer in this problem. Now we will move to the next problem. The next problem here. Our next problem is integral sin x minus cos x 1 plus sin x cos x. Okay, integral, total integral dx 0 to pi by 2. So this is our integral 0 to pi by 2 or pi by 2. Lower limit is 0, upper limit is pi by 2. Okay, the function is sin x minus cos x divided by 1 plus sin x into cos x dx. So take this integral 1. Now we will apply here, replace x to pi by 2 here. Okay. So see here 0 to pi by 2 sin pi by 2 minus x here minus cos pi by 2 minus x here also by the property of the definite integral. Okay. Divided by here also 1 plus sin pi by 2 minus x here. Similarly for cos pi by 2 plus dx. So tell me here sin pi by 2 minus x is equal to cos x, cos pi by 2 minus x is equal to sin x. Here or similarly sin pi by 2 minus x is equal to cos x, here cos pi by 2 minus x is equal to sin x. So write 0 to pi by 2, here cos x, from here sin x, divide by 1 plus cos x sin x dx. Just take it 2. Okay. Now we are going to add it this 1 and this 2. Okay. So by adding 1 and 2, integral limit is 0 to pi by 2. Okay. Just add it. Sin x. Take directly denominator because denominator is same in both. Okay. Here is also 1 plus here is 1 plus sin x into cos x. Here is also 1 plus cos x into sin x. Take denominator 1 plus sin x cos x. Just add numerator in both. Sin x minus cos x from there plus cos x minus sin x into dx. Sin x is cancelled from here. Cos x is also. So 0 to pi by 2, 0 into dx. Answer is 0 from here. Okay. Now we will move the next example here. Our next example is 0 to 4. Here Dibba is like box is greatest integer function. What? GIF. Okay. GIF takes only the integer value. Okay. So we will break it. What is our limit? 0 to 4. Okay. So break this function 0 to 1 x dx, 1 to 2 greater GIF into dx plus 2 to 3 dx. Okay. Next one integral into dx. So tell me from 0 to 1 GIF takes value 0. Okay. Value 0 equal plus from 1 to 2 it takes 1. Okay. From 2 to 3 it takes value 2. From 3 to 4 it takes value 3 into dx. So tell me this integral is 0, like 0 to dx 0. Okay. Now we will move forward. From here, tell me from here to here. What is the value of GIF 1? 1. Okay. So dx 1 to 2. Value of GIF 2 is 2. Okay. 2 outside. 2 to 3 dx. What is the value of GIF 3? This is the integer value. So we will take integer only. 3 to 4 dx. Okay. So from here I am going to direct integrate here. So 2 times 3 2 minus 2 here 3 times 4 minus 3. So from here 1 plus 2 plus 3 total 6. This is our final answer. Now we will move to the next example here. Now we will move the next example here. This x square full x. 0 here log t, next example x square to x square here. No, not this is not example. Wait, our example is fx is equal to x square to x cube 1 divided by log t dt. This problem is based on Newton-Leibniz theorem. So first I will tell you what is the Newton-Leibniz theorem. Okay, let hx Newton-Leibniz theorem. So let two functions is here, hx and gx. Hx and gx. Okay, these are the differential function. Both these two functions are differentiable function of x. Okay, so here fx is equal to d by dx integral lower limit is hx and upper limit is dx ft dt. We can write it also from here. First d by dx means differentiation. Okay, so f dash x is equal to here, just put first gx, so fx d of f, then differentiation of this value d dash x. This is our first. Take minus sign. Okay, now put lower limit. Okay, f of hx. Okay, what is the differentiation of h dash x? This is our Newton-Leibniz theorem. We have two functions hx and gx, both are differentiable with respect to x. Okay, so fx is equal to here, fx is equal to d by dx hx to gx. This is lower limit, this is upper limit, ft dt is the function. Now in equal f dash x is equal to put the gx here, then differential of the gx f gx g dash x minus, take the minus sign here, and f hx and differential of hx here. So now we are going to operate this Newton-Leibniz theorem in this particular problem. Okay, so see here, first we will operate the upper limit here. Okay, so 1 upon log x cube. What is the differentiation of x cube into 3x square? Generally I am telling you how can you operate the Newton-Leibniz theorem, because we have no more time here. So minus, take minus sign from here, f dash x. Okay, what is the lower limit? 1 upon log x square. What is the differentiation of 2x? This is the final answer. How can we operate the Newton-Leibniz theorem in the given problem? This is the answer. Okay, so now we move the next example. Integral 0 to pi x sin cos x dx. Okay, so not this problem. This is our problem. Integral 0 to pi sin 5x cos 6 dx. This problem is based on Wallis formula. Wallis formula. Now what is Wallis formula? Integral 0 to pi by 2 sin की power mx cos की power nx dx. What is this problem? Here first here m and n, I don't know what is m is odd or n is even. What is both are even or both is odd. Okay, we don't know right now. So here just multiply by the factor k here, and first just m minus 1, m minus 3, m minus 5 dot dot. Now we will break n minus 2, n minus 4 dot dot. Okay, divided by n plus n plus n minus 2 here, and n plus n 4, so on. So what is the value of k here? K is equal to, there are the two values, one is pi by 2 and another is 1. We will write pi by 2, when m comma n is equal to even. When write 1 here, except even, right, otherwise. If we have m comma n is even number, okay, then k is equal to pi by 2, except even number, k is equal to 1 here. Okay, now we are going to operate this concept in this particular problem. So here this x, now we can't directly operate the Wallis formula here, so we will break. Take this first, we will break into integral, like just replace x to pi minus x here. Okay, so equal to pi, here pi minus x sin 5, pi minus x cos की power 6 pi minus x into dx. So here sin pi minus x cos pi minus x, we will see it from the quadrant, from the trigonometry. This is the first quadrant, okay, sorry, not first quadrant, this is the first quadrant, this is the second, this is the third, this is the fourth quadrant here. Okay, here angle is 0 degree. Generally we will take angle in anti-clockwise direction from the positive x axis. Okay, so here angle is pi by 2, here is angle pi, correct, this angle pi, this angle is pi by 2, here 3 pi by 2, from here to here 2 pi. So see here sin pi minus x na, so sin pi minus x means second quadrant, in second quadrant sin will be positive. Okay, so here 0 to pi minus x sin power 5 x. What about cos pi minus x? So see here, cos pi minus x also in second quadrant. In second quadrant, cos pi minus x is equal to minus cos x. Okay, so here is the positive sign also, so we will take positive. Okay, cos x into dx. Okay, now we will break, here is the pi minus x into integral. Okay, from here 0 to pi into sin to power 5x cos to power 6x dx. Next one minus integral 0 to pi x sin to power 5x cos to power 6x dx. So tell me, what is the integral here? 0 to pi x sin to power 5x cos to power dx is equal to I now. So see here, x sin to power 5x cos to power 6x dx. Okay, just take it same I like that. So tell me here, integral 0 to pi from here equal to sin to power cos x sin to power 5x cos to power x dx is equal to this 0 to pi sin to power 5x cos to power 6x dx minus 0 to pi sin to power 5x cos to power 6x dx. integral 0 to pi here x sin to power 5x cos to power 6x cos to power 6x dx. So this integral is I na? Here this is I from here, this is also I from here. Okay, just take out, just this integral comes from this side. Okay, here is 2I, this I and this I. Okay, here is the right side is negative, so take it left side, negative is positive. Okay, 2I is equal to integral 0 to pi here pi sin to power 5x cos to power 6x dx. Okay, here we will see here 2I, wait, two I equal to what is 0 to pi sin power 5x cos to power x cos to power 6x dx. Okay, just take pi is constant outside and divide here by 2 and multiply by 2. Here 2 0 to pi by 2 sin 5 cos 6x dx. Here 2 to cancel, so I is equal to pi 0 to pi by 2 0 to pi by 2 sin 5x cos 6x dx. So this is the form of Wallis formula na? Just apply here Wallis formula. What is our Wallis formula? So see here, m is equal to 5, n is equal to 6. Both are the one value is even and one value is odd. Okay, so take k value is equal to 1. So 1 into 5 minus 1, 5 minus 3. Okay, into what is 6? 6 minus 2, 6 minus 4. Here multiply m plus n, 5 plus 6, 5 plus 6 minus 2. Here here 5 plus 6 minus 2 minus 4 minus 6. Okay, so see here 5 minus 1 is equal to 4, 5 minus 3 2, 6 minus 2 4, 6 minus 4 2. Here 11, here 9, here 6 5 11 minus 4 7, 5 6 11 5. Next one 5 plus 6 8. So from here this is 3. Next one 5 plus 6 10. Okay, so from there this is 1. Just solve this integral. From here this is 2 to the 4 64 in the numerator here. Okay, and in denominator 9 5 1. Just multiply to the denominator. This is our final answer. So this is our demo lecture, because we have no more time. There are many more like reduction formula, and there are many 1 and 2 concept more in the integral, like how to solve the series in this, like this series, like we are going to problem 1 plus n dot dot infinity limit and tending to infinity, how to form in the series to integral. There are the many more concepts here, but we have no more time. This is the demo lecture, so we will stop here. Thank you so much.